Hi, welcome back to Mr. Class. This video is going to focus on 1.2 more concept which more related with the molecular formula. First, we are going to define the term for the empirical and molecular formula. Second, we are going to determine the empirical and molecular formula based on the mass composition given. Sound like familiar, right? Yes, these are the things that you learned before. However, the new things that we learn today is we have to determine the empirical and molecular formula, but it's based on the combustion data given. This slide just want to recall the definition for the empirical formula and also molecular formula, and then just recall back the relationship between the empirical formula and also molecular formula. Okay, let's look at the first example. Basically, you learned this before, at where the composition of the element is given is percentage. So to answer this, first you have to do the assumption there is 100 gram of sample. Then you will draw a table which first contain element, second is the mass, third is the number of mole, and then the last one is the simplest ratio. Because of we already assume the compound is in 100 gram, therefore, later the mass here, which is in gram, is similar with the number in percentage. Okay, so means that you just directly copy the value given in the question into this box, and then use the average, divide by the average atomic mass to get the number of mole. To get the simplest ratio, you will divide with the smallest number. Okay, this is the smallest number. Okay, then you will notice you will get 1, 1.34 and 1. Which this 1.34 we cannot round off to become 1. We have to multiply with a whole number. Okay, so in this case we multiply with 3. So the other 2 carbon and also oxygen also we will multiply with 3. Then you will get 3, 4.02 and 3. At this moment, then we can round off 4.02 to 4. So the empirical formula is C3H4O3. Okay, one point to remember, never round off to a whole number. Okay, but you can multiply by a factor until you get a whole number. Take the example 1.34 that appear in the question. We will not round off to 1, but we need to multiply by a factor. Let's say we start with the smallest factor, which is 2. We will get 2.68. In this case, we also cannot round off to 3. Then if 1.34 multiply with 3, we will get 4.02. In this case, we can round off to 4. In simple words to say, we only can round off if the difference is in between 0.01 to 0.09. Okay, then in this case, we can round off. Okay, if you round off to 3, so the difference is 0.32. So this is not in the range, so cannot round off. Next, the difference is 0.02. So this difference is in this range. So this can be accepted. Let's check with another example here. Let's say I have 1.27. We cannot round off to 1 because the difference is 0.27, which is not in this range. Next, 1.27 multiply with 2, I will get 2.54, which we also cannot round off to 3 because the difference is very obvious, it's not in this range. 1.27 multiplied with 3, we will get 3.81. Also cannot round off to 4 because the difference is still greater than the range suggested here. 1.27 multiplied with 4 is equal to 5.08. Yes, in this case, we can round off to 5. Okay. Last part of the question, we have to determine the molecular formula by using the relation between empirical formula with the molar mass to determine the n value. Basically, the n value supposedly is nearest to whole number or is a whole number. So if you are not getting the whole number in this case, then please check your empirical formula. So which part of the empirical formula determination step of empirical formula you need to aware basically is the mass. Did you copy the correct value from the question, or did you press the correct press the correct value in the calculator? If it is correct, then maybe you can check for the simplest ratio. Are you round off without multiply by a factor? If yes, then please multiply by a factor so that you will able to get the whole number here. After you get the whole number, then only we will able to get the molecular formula. By using the example that we discussed just now, now it's your turn to answer tutorial question number 5. Okay, when we go through the question, basically again, we look at the information given. The mass is given in terms of percentage. So means that first you have to do assumption. So second, you have to draw the table which contain element, mass, number of mole, and simplest ratio to determine the empirical formula. Then next, use the relationship between the empirical formula and also the molar mass to find out the n value. So make sure the n value is whole number, then you will get the molecular formula. Okay, question 6 is slightly different from question number 5. Why we say it is slightly different? Because the composition of element is given in percentage. However, there is no molar mass in this question. However, the mass of one molecule of A is given. But then we know molar mass is referring to the mass for 1 mole. So we know in 1 mole of A, they will contain 6.02 exponent 23 molecule of A. So if I want to look for the molar mass, so I need to use the Avogadro constant multiplied with the mass of 1 molecule of compound A, at where this is the molar mass of compound A. Okay, so the working step is still the same, so you can try it out yourself, and then this is the answer for empirical and molecular formula respectively. Okay, now we are in example 2. If you still remember, in the previous video, the last tutorial question, we did mention about hydrated compound. So means that in the general hydrated compound formula, you will see like this with a dot and then a number with H2O. Okay, this is called hydrated compound. And then in this question, basically you can see they let us know there is 4 gram of calcium, 7.1 gram of chlorine, and 7.2 gram of water. When the percentage is not given, so generally we no need to do assumption. So if you look at the solution here, there is no assumption. Okay, assumption in this case is not needed. Okay, because percentage is not given. Okay, then next you will notice actually still the same. You need to have element and then the mass, the number of mole, and also the simplest ratio, then you can determine the empirical formula. Okay, this is the last example that we are going to discuss, and it is a new type of question. Generally, you will notice the mass of carbon dioxide and the mass of water will be given. So when these two information are given, we consider this question is relate with the combustion data. Okay, why we say these are combustion data? Because generally oxygen will be supplying into a sample at where we continue to do the heating, at where this is a combustion process. So generally we know that combustion always will produce water and carbon dioxide. So the water that produced in the combustion will be trapped in this U-tube, while later water is already trapped here, then carbon dioxide will trap by this adsorbent here. So and then the unused water or the extra oxygen will be removed out. Okay, now let's check it out. How the combustion data can help you to determine the empirical formula and also the molecular formula. From this question, compound A contain carbon, hydrogen, and oxygen. And then when we burn 1 gram of the A, it will produce 2.52 gram of carbon dioxide and 0.44 gram of water. So as we know, if we want to determine the empirical formula, besides knowing the element is the first thing, element, then second things that we need to know is the mass for each element. Okay, so now we need to know how we can find the mass of carbon. So we know that this ethanol, okay, for example, this is the ethanol. So when we burn this ethanol, all the carbon will trap in the carbon dioxide absorber. So means that all the carbon in the ethanol will be present in the carbon dioxide. Okay, while the hydrogen in the sample will be absorbed by this water absorber, which also all the hydrogen is contained in the water. So after we get the mass for carbon and hydrogen, so we use 1 gram to minus the mass of carbon and then minus the mass of hydrogen. So it will be the remaining will be the mass of oxygen. Once we know the mass, then we can find the number of mole. After we find the number of mole, then we can find the simplest ratio. Then we can know the empirical formula. After we know the empirical formula, and then look at this question here, you are given the molar mass. So means that you can use the relationship empirical formula and the molar mass to find out the n value. And then last, you can determine the molecular formula. So basically, this is the idea for the combustion data. So the whole thing, from here so many steps, the most important part is the part that you determine the mass. Once you can determine the mass, then you can answer this question. Now, let's look at how we're going to determine the mass of carbon in carbon dioxide. So we always will use 12 because this is the mass of carbon over or divide by the mass of carbon dioxide. This is 44 is the molar mass for carbon dioxide. And then multiply with the mass of carbon dioxide, which is from the questions here. Okay. Next, we are going to look at mass of hydrogen. So mass of hydrogen, we will use 2 minus 1, 2 multiplied with 1. Why 2? Because here has 2 hydrogen atom in the water molecule. And then 1 is because the atomic mass of hydrogen. Then we divide by 18 because of the molar mass of water. and this 0.443 gram is the mass of water produced. Okay, so from here we already get the mass of carbon, and then we have the mass of hydrogen. So go back to question. If you still remember, the question mentioned we burn 1 gram of A. So in this 1 gram of air, they supposedly contain carbon, they supposedly contain hydrogen and also oxygen. So we already have the mass of carbon and also hydrogen. So if I want to find the mass of the oxygen, means that the remaining of the mass will be mass of oxygen. So we are going to use 1 gram minus mass of carbon, which is 0.6873, and then minus with the mass of hydrogen, which is 0.0492. So this remaining will be the mass of oxygen. Okay, in the beginning of the question, we already know that we need to find the empirical formula. So once we want to determine the empirical formula, first thing we need to have the element. So from the chemical formula given, we already know the compound A contains carbon, hydrogen, and also oxygen. Based on the combustion data in the previous slide, we already determined the mass of carbon, hydrogen, and oxygen as well. So step number 3, we are going to determine the number of mole of each element by divide with the atomic mass. Okay, so step number 4, we are going to look for the simple mole ratio. So as you look at here, this is 3.5, and then we know that we cannot round off to 4. We have to multiply with a factor. So in this case, 3.5 is very obvious. When we multiply with 2, so we will get 7. And then 3 multiply with 2, we will get 6 for hydrogen, and oxygen we multiply with 1 with 2, so we will get 2. So this is the empirical formula for the compound. Okay, but when answering the question is asked us to determine the value of x, y, z. So you have to put it at 7, 6, and z respectively. So the next one, the question also asks us to look for the molecular formula. So again, we are going to use the relationship between empirical formula with the molar mass. So when you do the calculation, you notice that the n is equal to 1, which is the whole number. So basically, we will believe that the empirical formula that you determined earlier is correct. Okay, so because of n equal to 1, therefore empirical and molecular formula will be the same. Okay, but in this question, they ask us the molecular formula, so you just write down the molecular formula lah. Okay, that's all for this question. Okay, now it's your turn to do tutorial question number 7. You will notice this question basically is similar the previous example that we discussed. So in this question is given compound R. Just now is given us compound A. Compound R 3.5 gram. Just now compound A is 1.0 gram. Okay, contain carbon, hydrogen, and oxygen. Next, they say they burn completely to produce 5 grams of carbon dioxide and 2.5 grams of water. So basically, again, they also give us the mass of carbon dioxide and mass of water. So if you want to find out the mass of carbon, so always equal to 12 over 44. This time, the mass of carbon dioxide given in the question is 5 grams. So we are going to multiply with 5. Okay, let's say later you will get the air value. And then mass of hydrogen, still the same. We are going to use 2 times 1 divided by 80. And then multiply with the mass of mass of water given in this question. Let's say later you will get the B gram. Then how you get the mass of oxygen? So you will use 3.5 gram minus A minus B. Okay, so let's try it out yourself, and then this is the final answer, C2H5O2. Okay, you can check out this link to get some idea of the common mistake made by the students. Okay, so that's all for this video. Thank you.